will present about how analytical chemistry ensures safe drinking water using a volumetric analysis. For introduction, we have analytical chemistry play a crucial role in guaranteeing that drinking water is safe for humans' consumption. It involves the use of a chemical technique to detect, measure, and monitor contamination such as hardness ions, chlorines, heavy metals, acid, alkali, and pollutants. By applying analytic methods, volumetric analysis, we have a good use titration. Scientists and water treatment facilities can ensure that water meets national and international safety standards. Next, we have what is volumetric analysis. Volumetric analysis is a branch of analytic chemistry that determines the concentration of unknown solution by reacting with a solution of known concentration, called a standard solution. And then we have this process is carried out through saturation, a controlled chemical reaction where volume change are measured to find the amount of substance in water. We have why volumetric analysis important in water treatment. Volumetric analysis is widely used in water treatment because it allows accurate and acquired measurement of important water quality parameters. We have 5. To determine hardness, calcium and magnesium ions. To measure chlorine level, use of disinfection. To check acidity or alkaline pH control. To monitor pollutants such as nitrates or heavy metals. And the last one, to ensure treated water meets safety standard WHO or EPA. This helps prevent waterborne disease and ensure the water is safe for the public.
The theory of titration concept. Titration is based on the principle of a known reaction between two chemical substances. Volumetric analysis is a quantitative chemical analysis method that uses titration to determine the substance in solution. The type used in redox titration is the oxidation and the reduction. Now, we move to a methodology how to perform a water titration. First one, we need to set up all the apparatus needed. Then, we move to the first procedure, which is we need to take the water sample. Then, rinse the burette with the EDTA solution and fill it up to a 0 mark. And then, we need to pipette off the water sample into a conical flask. Add of a buffer solution to maintain alkaline condition. Then, add a few drops of black tea indicator. Titrate the EDTA from the burette. As you strain, observe the color change. Record the final burette reading and repeat for 2-3 trials and calculate the mean volume. Now, we move to...
So this is the example of result. The raw titration results obtained from 3 trials using EDTA titration to determine water hardness. From all 3 trials, the initial burette reading is 0.00 ml. The final readings are 12.40 ml, 12.30 ml and 12.35 ml. Therefore, the volume of EDTA used in each trial is the same as the final reading. To improve accuracy, the average volume of EDTA is calculated by adding all 3 values and dividing by 3. The average EDTA volume obtained is 12.35 ml, which is equivalent to 0.01235 liter. The given data included molarity of EDTA solution, which is 0.0100 m, volume of water sample titrated 25.0 ml, and the mole ratio between EDTA and hardness ions is 1:1. These values are used in the next slide to calculate the concentration of hardness ions. This is the step-by-step calculation used to determine water hardness. First, the moles of EDTA used are calculated using the formula moles equal to molarity by volume by multiplying 0.0100 mole with 0.01235 liter, the most of EDTA used is 1.235 times 10 to the power of negative 4 mole. Next, since the mole ratio between EDTA and hardness ions is 1 to 1, the moles of hardness ions are also 1.235 times 10 to the power of negative 4 mole. Then, the concentration of hardness ions is calculated by dividing the moles of hardness ions by the volume of the water samples in liters, which is 0.02500 liter. The concentration obtained is 0.00494 mole per liter. Finally, the concentration is converted to mg per 100 ml as calcium carbonate CaCO3. Using the molar mass of CaCO3, which is 100 gram per mole, the hardness value is calculated as 49.4 mg per 100 ml. This value represents the hardness of the drinking water samples.
The conclusion is analytical chemistry is the foundation of a modern water quality assessment. By applying precise scientific methods such as spectroscopy, titration, pH measurement, and metal detection, chemists ensure that every drop of drinking water meets strict safety standards. This technique helps identify contaminants early, guide effective treatment, and protect community from harmful chemical and disease-causing microorganisms. In a world where pollution, aging infrastructure, and environmental change continue to threaten water source, analytical chemistry remains essential for safeguard public health. Ultimately, river water testing builds trust, prevent health risks, and ensure that clean, safe drinking water is accessible to everyone.